This afternoon, we will discuss principles of counting. We will be reviewing combinations, permutations, and then later probability. Now, there are several principles of counting, and let me begin by emphasizing principle of counting for simultaneous and successive events. So simultaneous or successive. Now, when we say simultaneous, it means to say that one event will follow after the other, and the next one, when we talk of simultaneous or rather simultaneous events, one is happening with the other. That is the difference between simultaneous and successive events. Oops.
Sir, nakamute ka, sir. Sir, excuse me, sir. Nakamute ka, sir.
Yeah, thank you. Okay, so the principle of counting for successive or simultaneous events. Okay, it says here, this is for, again, for successive or simultaneous events. If an operation can be performed in K1 ways, and if for each of this, a second operation can be performed in K2 ways, and for each of the first two, a third operation can be performed in K3 different ways, and so forth, then the sequence of n operations can be performed in K1 times K2 times K3 up to Kn ways. So this is how to calculate the number of possibilities. So we call it principle of counting because we don't have to count it one by one, and we just rely on the formula, which is multiplication. And just to illustrate, we consider, say, travel from A to C, but then you have to pass by point B. So probably for us to imagine, suppose this is the Talamban campus, and this one here is the Ayala Center. and this is the downtown campus, DC. And if you are going from DC to downtown campus, you can choose the following roads. You can take from A to B, road number 1. So probably this is the Archbishop Reyes. And then from B to C, you will also be following road number 1. So this is one possibility. It's also possible that somebody will travel from A to B using road number 1, and then from B to C, road number 2. Or maybe from A to B, route number 2, followed by 1, or 2 followed by 2, or maybe 3 followed by 1, and 3 followed by 2. So all in all, there are 6 different ways. You can count it one by one, or you can just use the principle of counting, recognizing that this is a case of successive events, one event followed by another. So in this particular example, the first event can be done in 3 different ways. So the K1 is 3. After which, the second event can be performed in 2 different ways. That's now the K2. And because there are only 2 successive events, then we calculate the total number of ways by multiplying K1. So whatever is the value K1, multiply it by the value K2. So that is the essence of this principle, the fundamental principles of counting. Another example is if you are going to toss a coin 3 times. I repeat, the experiment, by the way, in this particular subject matter, if you talk of experiment, it could be any activity in which you can gather information or you can gather data. So tossing a coin is considered an experiment, and if you toss a coin, there are several informations that you can obtain. Now in this particular case, we are interested of tossing a coin 3 times, and we will take note of the number of possible outcomes. So possible outcomes. Now, these are listing them. These are the possible outcomes. The first toss will give a head. The second also head, and the third one is head. And this is one possible outcome of tossing a coin 3 times. It is also possible to have head followed by head, and the last toss is tail. Or it might be that the first is head, the second is tail, and the third is head. This is another possible outcome. Or first one is tail, then followed by head and head. Okay. It could be also tail, tail, head, or tail, head, tail, or head, tail, tail, or finally tail, tail, tail. And you cannot add another possible outcome to this. There are only 8 possible outcomes. And how do I compute the 8 possible outcomes? I will just answer the question, how many outcomes in the first toss? In the first toss, there are 2 outcomes. In the second toss, there are also 2 possible outcomes. And in the third one, there are also 2 possible outcomes. And according to the principle, you just multiply. The first event can be done in 2 different ways, followed by another event which can also be done in 2 different ways. And the third event will follow the second also. There are 2 possibilities. So you just multiply 2 times 2 times 2 equals 8. you can apply the principle of counting, do the calculation, or you can list the possible outcomes, then count them directly. But of course, this one is challenging, especially if we talk of so many outcomes or possible outcomes. Like, for example, if you will be asked how many plate numbers we could form if we start with 3 liters, 3 liters, naman ay karon sa Cebu, no? 3 liters, and then followed by 4 digits, then how many plate numbers we could form? Of course, we can do the calculation using the principle of counting, or you can list all of them, and it will take you very long time because there are so many possible outcomes in this particular requirement. I hope that principle of counting is clear to all of us. Next, I would like to differentiate permutation from combination. What's the difference between the two? Permutation and then combination. When we talk of permutation, we are interested of grouping objects, but we consider the order of the elements in the group. What I'm trying to say is that if you mean that 238 is different from 283, if the two are different, then you notice there are exactly the same elements in the group, but what made them different is the order of the elements, and therefore this grouping is what we call as permutation. This is another permutation, and so on. And therefore, if you have 3 objects, there are 6 different permutations. You might ask, what are the situations where these 2 are different? Well, if you are talking of numbers, or if you are talking of amount of money, if it's different by saying 238 compared to 823, when in fact all the elements are exactly the same. But if we talk of money, we always prefer 823 over 238. If somebody will give you money, so you will choose the 823 because you believe that this one is different from 238. Again, what made them different is simply the order of the elements. And if that's the case, then we call such grouping as a permutation. I hope that's clear, no? A combination, on the other hand, is also order. Rather, it's a group of elements, grouping of items or objects, but the order is not important. Okay, so if we look at the above example, let me first erase the writings. If you say that this one is not different from 823, then the 238 and the 823 would be considered as is the same group, then such grouping is combination. Now, I'll give you an example. If we are talking of contestants, no? For example, kanang sa marathon, and we have the following contestants. Naay usa ka runner nga ang iyang number is 2, another runner is 3, and another runner is 8. And then somebody would say, who are the finalists? If the contest, for example, will first choose 3 individuals, and then the 3 again will compete each other, as if qualifiers, no? And then if there are only 10 participants, and you you would now declare that contestant number 2, number 3, and number 8 are the finalists, then it's not different when somebody would say the finalists are 8 to 3, because we are referring to the same persons. And we haven't attached yet ranking to these persons. So by just mentioning 8 to 3, it's the same information as 2, 3, 8 if we talk of who are the runners considered as finalists. Then such grouping is combination. Now, here are some examples of combination. If you select members for a committee, so if you choose members to form a committee, assuming you have a person named Pedro and Pablo, and then another person is Maria, okay, Pedro, Pablo, and Maria, and then somebody would ask, okay, who are the representatives? Who are the members of the committee? And somebody would say Pedro, Pablo, and Maria. And others would, and another person would say, no, they are not the representatives. And he will declare, well, the representatives are Maria, Pablo, and Pedro. I think that's not different compared to the first declaration, right? So in combination, the order of the elements is not important. Another example is drawing numbered balls to determine a jackpot in Lotto. So in Lotto, the order is not necessary. What's important is only the number in the 6 combinations, no? That's in Lotto. Drawing cards from a deck of playing cards. So example, if somebody will get 2 cards from the deck of playing cards, and then the cards in the hand are ace and king, say ace and king, and then he will declare, my cards are ace and king. But somebody would say, no, that's wrong. His cards are king and ace. That's not different. It means the king and ace still the same as ace and king if you are just interested of what are his cards. These are examples of combination. So I hope the difference between permutation and combination is clear. Let's focus now on the permutation. There are several formulas that you have to understand, and not only understand, also memorize. If you cannot memorize, then remember the formulas. The first one, the number of permutations of n objects taken all at a time is calculated as n factorial. No? N factorial. We already understand the meaning of factorial. If somebody would say 5 factorial, I hope that everybody in this meeting understands that it is 5 times 4 times 3 times 2 times 1. So it's the product from 5 to 1, inclusive, no? Including 5. Take note that 5 factorial can also be rewritten in the form of 5, then multiply it by 4 factorial. No problem with that, no? Because 4 factorial is simply 4 times 3 times 2 times 1. So basically, n factorial would be the same as saying n, multiply that by n minus 1. We already encountered this before, no? N factorial is the same as saying n times n minus 1 factorial. 0 factorial is 1, 1 factorial is 1. N factorial is also the same as n times n minus 1. You can continue decreasing the n, so n minus 2, provided you place factorial at the end. It's still n factorial. So when we talk of the number of permutations of n objects taken all at a time equals n factorial. To verify that, you apply principle of counting. So what is that principle of counting? Consider n objects. So we have the following objects: 1, 2, 3, 4, up to n. So there are n objects. And you want to get the grouping of all the objects. So to be able to form a group, you are going to provide enough spaces to collect the group. Meaning, you have to provide boxes. And what are these boxes? Well, you will declare it as this one is n. This is now n minus 1. This is the third box. I think I have to, instead of doing it that way, I will do it this way. No? To be more understandable. So we consider, once again, we consider n objects. 1, 2, 3, and so on, up to n. And then you are going to group these objects. And these are now the different boxes that you have to allocate to accommodate all objects. Meaning, you have also to consider boxes like first box, the second, the third, up to the nth box. And it might be that this box here is R, no? The question is, since according to the principle of counting, you just determine the entire event into sub-events. And in the sub-events, you would say, there are how many ways of assigning an object to the first box? Again, the basic question is, how many ways by which you could assign an object to the first box? Considering this as the candidates. So there are n objects, and therefore, there are n possibilities of putting an object in this box. For the second box, because an object has been taken already from n objects, it means to say that there are n minus 1 remaining objects, n minus 1. And the n minus 1 remaining objects can be possibly assigned in the second box. Now that there are 2 objects taken, because the first one is assigned to box number 1, the other is assigned to box number 2. So here, there will be n minus 2 remaining objects that can be assigned to box number 3. And you can imagine that in the last box, there will be one left or one object left, and we don't have any other choice but assign it as the last object. And if you notice, since we will be multiplying the numbers in the boxes, so the multiplication is simply n times n minus 1 times n minus 2 up to 1, which is exactly n factorial. Okay, so I hope that's understood. If in case there are things that you want to be clarified, please do not hesitate to interrupt me. Next one, the number of permutations of n objects taken are at a time. Okay, so once again, there are n objects, but you don't want to collect all of them at the same time. You are going only to collect R objects out of n. So this is box number 1, box number 2, box number 3, number 4, and so on. Okay, I'll just say and so on. And this is now box number R, because we want to collect only R objects. We don't want to collect all of them at a time. We only collect R objects. So going back to the question, how many ways could you fill up box number 1? Obviously, since there are n objects from the list of choices, then we could possibly assign n objects in box number 1. The same explanation in the second box, we have n minus 1. In the third box, n minus 2. And then, and so on. In the art box, if this is R, then this is represented now as n minus R minus 1. Right? Because if this is the second box, it will become n minus 1. Third box, n minus 2. The fourth box, n minus R minus 1. So, the number of permutations, NPR, is calculated as n times n minus 1, multiply it by n minus 2, and you keep on multiplying until the last number, where the last number is n minus R minus 1. That's it, no? But this one is a long formula. So to make it shorter, you can modify this. How? By multiplying this value. You can multiply this by n minus R, where n minus R should be the next number in the sequence, because this is n minus R minus 1. So if I'm going to multiply n minus R, and I will place factorial at the end, I am now changing the value, so that the value is not changed. Then I have also to divide it by n minus R. And there is no effect, because n minus R factorial over n minus R factorial is simply 1, but the sequence n up to n minus R factorial is equivalent to n factorial, the one that we defined earlier. And in the denominator, we still have n minus R factorial left. Therefore, the formula now is the number of permutations of n objects taken R at a time is NPR, which is n factorial over n minus R factorial. Questions so far? Okay, maybe I can ask Dinmar or Ropel. Do you have any question, Dinmar? Dinmar? Hello, Dinmar? Wala, kasi di na ako malungog ninyo, no? Let me check on Ann Feliz. Ann Feliz Chua? Hello? Yes, Jel. Okay, thank you, Jel. Any question, Jel? Jerusalem?
None so far, sir.
Okay. So I thought nga di ko makadungog ninyo. So thank you, Jel, for the feedback. Uban waman. So we'll try Gabriel. Ihano, Gabriel.
None so far, sir.
None so far. Thank you. Next, another formula is when we are interested of arranging objects around a circle, or we call it cyclical permutation or circular permutation. The number of permutations of n objects arranged in a circle is calculated as n minus 1 factorial. Now, the formula will count arrangement in this manner, no? if you are going to arrange objects around a circle, say for example A, and this one here is B, and this one is C, and then you are asked to rearrange the object. Now, when we say rearrange the object, and then you propose that you place A here, and then B, and this one here is C. Well, this arrangement number 2, is not counted different from arrangement number 1. The reason for that is if you are going to rotate, arrangement number 2 counterclockwise, then you will just be able to duplicate arrangement number 1. In cyclical permutations or circular permutations, the two are not different. They are considered the same. Therefore, to obtain a different grouping, this is what you will do. Now, this is what you will do. If there are n objects arranged around a circle, so in this case, what you need to do is you fixed one object. Do not transfer that object. Meaning, of the 3, you fixed 1. And then you rearrange the remaining. If you do that, then you would be formulating another group which is different from the first group. That will explain the formula n minus 1. So of the n objects, you fixed 1. Meaning there are only n minus 1 left to be rearranged. And if you rearrange n minus 1 objects, then the formula is n minus 1 factorial. We encountered this already in the first formula. Another one, the number of permutations of n objects of which n1 are alike, n2 are alike, nk others are alike, you calculate it in this manner. Take note, if there are alike objects, you will lose some permutations. I'll give you an example. If we consider the letters in this particular word, assuming we have like that, seeds, and then you are asked to rearrange all the letters. Now, suppose this one is different. The E1, suppose if E1 is an object which is different from A2, you will be obtaining a different permutation if you interchange E1 and A2. Diba? This could be already different had the objects are different. But in this case, they are exactly the same because some objects are alike. So instead that this is 1 and this is 2, this cannot be considered a different grouping because it looks exactly the same as the first one. And that is due to objects which are alike. So you have to reduce the number of permutations. And how to reduce? You divide the total number by n1, where n1 represents the objects that are alike. In this case, n1 is 2 because there are 2 is. n2 is also 2 because there are 2 s's, another s. And we don't have other objects which are alike. So we just say 5 factorial, then 2 factorial, 2 factorial. And that would be the number of permutations of n objects of which n1 are alike, n2 are alike, and nk others are alike. The formula for the combination that is NCR, mao ni ang built-in na formula sa calculator, NCR. So in CR, we say n factorial, then all over n minus r factorial, r factorial. So this is the formula for in CR. In CR is also the same as in PR, divided by r factorial. Diba? In PR, ang in PR, if you recall, in PR is this one. This is in PR. If you divide it by r factorial, what you are getting is in CR. So I hope wala tayo questions or clarifications. Maybe we can proceed to some sample problems. Okay, number 1. In how many ways can 4 boys and 3 girls sit in a row if the boys and girls alternate? In how many ways? So, since there are 4 boys, ang possibility ini mag-provide ta og 7 seats. So we have 1, 2, 3, 4, 5, and 7. Kini boys yun di ba? Or boy. Kini girl. Alternate man kuno sila. Butang ta lang boy number 1, girl number 1, boy number 2, girl number 2. Boy number 3, girl number 3. So there are only 3 girls and there are 4 boys. So this is one possibility. Now if boy number 1 and boy number 2 will exchange places, so that's another arrangement. Okay, di man pwede nga kung ang boy number 1, for example, si Pedro. Pedro na siya. Kini boy number 2 is si Pablo. Unya ang si Pedro na-crush ining girl number 1. Butanta si Joy na siya. Mumatter na gyud. Moingos Pedro, kung imo kong i-transfer here, layo na ko ni Joy. So, that would be considered a different group, a different arrangement already. Okay, so when you change the places of the boys, then there are 4 possibilities because there are 4 boys. Okay. Then simultaneously, the girls can be also arranged in 3 different or 3 factorial different ways. So in total, if you apply the principle of counting, the boys can be done can be rearranged in 4 factorial ways. And the girls can also be rearranged in 3 factorial ways. So you can view this as simultaneous events while the boys are transferring from one seat to another. The girls are also doing that. And there are 144 different arrangements. That's for problem number 1. Okay, problem number 2. In how many ways can 12 children be assigned to 3 playing rooms? So there are 3 playing rooms. Number 1, number 2 here, and number 3. The playing rooms, the capacities here 3. The capacities here 4. There are only 4 capacities in 5. Pre-pandemic pa niya kay ang mga children di pa man allowed kung pandemic. So wala pa ni pandemic or probably after the pandemic. There are 12 children. So unsaon man napagbahin nimo ang 12 children? Okay. So in total, pila man this is also 12. So if you are going to place 3 children here 4 children, and 5. The idea, if you are going to rearrange the three children in the same room, they are still the persons in the room. Meaning, rearranging the three objects in this particular cell will not give you another possible outcome. And the same thing here. The same also for the last room, which has a capacity of 5. What would be considered different? And consider different, assuming that 3 individuals here are, as an example, balik ta ni Pedro, na kapoy na ginis Pedro, si Pablo, o si Joy. Now, if the 3 persons in playroom number 1 are Pedro, Pablo, and Joy, then the arrangement would be different if Joy is transferred to the other room. So that's considered different. When somebody maybe from 5 will be transferred to number 3. Follow? And then another person here is transferred to number 5. So this is now considered different. And how to solve this kind of problem? This is what we call as partitioning. No, partitioning. It is just like 3 or objects that are alike. So in this case, the 3 persons in playroom number 1 are considered the same objects or alike objects. In cell number 2, the 4 alike objects. In cell number 5, also 5 alike objects. So the formula is n factorial divided by 3 factorial, 4 factorial, 5 factorial, or in total, 27,722 different ways. Okay, I would like to pause for a while, and I would like to entertain questions if there are questions or clarifications. Questions? Wala? Okay, ato dong i-check si Malcampo. Malcampo, you have any question or clarification?
None, sir.
None, no? Si Jeff? Jeff? Hello, Jeff? Wala si Jeff. Belarmino?
Sorry, sir.
Okay. Jomel, Belarmino? According to Jomel, none, sir. How about Poros?
None, sir.
Okay. So, ningon si Jomel, review ragyo ko no sa senior high school. No, senior high school gini nga topic niya oman. Actually, encounter sa ninyo sa inyong probability and statistics, most likely, no? Okay, Kinesia, there are 3 different kinds of toys, car, airplane, and boat, are available for distribution to 15 street children. If each child can receive at most 1 toy, how many possible selections are there? Okay, so in this particular case, we view it as NPR, no? NPR. And it's considered NPR because the objects, the car, the airplane, and the boat would be considered different. And if you are that boy, and you receive a car, a toy car, it's different for you if you receive an airplane or a boat, di ba? So in this particular case, mo matter ang gift na imong ma-receive. Okay, here is another one. Find the number of ways that 10 CE teachers can be assigned to 6 sessions of tutorial classes if no teacher is assigned to more than one section. So, nato ning illustrate na kay teacher number 1, teacher number 2, teacher number 3, and so on, teacher number 4, and there are 10 teachers. So, teacher number 10. And there are 6 rooms, no? Tutorial rooms. Tanroingon diha para ma-visualize nato ang corresponding formula. Okay, there are 6 rooms, so you have to choose 6 teachers. Then it could be that teacher number 1 is chosen. Nya i-assign siya dire. Teacher number 2, teacher number 3, teacher number 4, and maybe here teacher number 9. Yeah, teacher number 10. So, this arrangement is different if you assign teacher number 10 here. Kay probably ang course dire is algebra. Nya dire trigo. Kay these are 6 sessions of tutorial classes, and then no teacher is assigned to more than one section. So the solution is NPR because you just choose 10 or 6 out of 10, no? 6 out of 10. And then the teachers that were chosen, 6 of them, if you assign them to different rooms, say for example A, yeah, B, C, D, E, and F. It would be different if teacher number 10 is assigned to classroom A. It would be different if teacher number 9 is assigned to room F. Okay, so this is one possibility. Another possibility, another possibility is teacher 1 dire, teacher 2, teacher 3. Pero sa D, si teacher number 7 na. Oh, this is a different arrangement. Okay, nato, no? This is a different arrangement. Ato lang i-change ang T4 to T7. This is now different. So, difference up na kung atong interchange ang T4 o T1. That's why we consider it as permutation because the order is also important. That's the interpretation. In this case, in how many ways can 5-player starting unit be selected from a 12-member basketball squad? Familiar man tayo no? So, sa basketball team, na may gitawag nato og first 5. Tanta lang natay mga players na A, B, C, D, E, F, G, H, I, J. Pila naman 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 12 man. O, kuwangan patagduha. So, napay player K, napay player L. And then you have to choose the first 5. Now, kung ang first 5 na imong i-choose is A, B, C, G, and H. So, mo na yung first 5. It will not matter kung mingon ka, no, I don't like A, B, C, D, G, H as first 5. Yeah, you will be asked, kung sa man preference nimo, and then you would say, mas ganahan ko nga si G, H, o Onya CBA as the first 5. Well, this is not different from the first group. Diba? It's basically the same. And therefore, the order of mentioning the players is not important. We are only interested of who are the players to compose the first 5. And therefore, this is combination. So this is considered one combination kana. This is considered as 1 if you count it. And this is different. A, B, C, G, but this time you choose I. So this is another possibility. This is number 2 already. Pwede sa A, B, C, G, and J. That's another possibility. That's number 3 already. So this is what we call direct counting. Now, if you cannot afford to waste your time counting it, then you just use the formula. And the formula is combination, that is 12 combined 5. Okay, let's analyze this. From the digits 0, 1, 2, 3, 4, 6, and 7, how many 3-digit numbers can be formed if, number 1, each digit may be used only once in the number. Now, this kind of problem, you solve it using the principle of counting. I repeat, use the principle of counting. Understand that you are going to form a 3-digit number. You are going to form a 3-digit number. Then I suggest that you draw 3 boxes. Now this box is intended for the hundreds digit, this is for the tens digit, and this is for the unit digit. There are some restrictions here because there's a number 0. If you place 0 here, you are not able to form a 3-digit number. Diba? Kaya kung ang 0 na, for example, 1 and 2, then you are talking of 12 only. It is not a 3-digit number. Therefore, you cannot assign 0 as the hundreds digit. If that is the case, due to such limitation, you would say that of the 1, 2, 3, 4, 5, 6, 7, of the 7 candidates, only 6 candidates are allowed here. It could be candidate or it could be 1, and we are talking of 3-digit number beginning with 1. It could be 2, meaning a 3-digit number starting with 2, or 3, 4, 6, or 7. So there are 6 possibilities of assigning a number as the hundreds digit. 1, 2, 3, 4, 6, and 7. What about the tens digit? For the tens digit, there are also 6 possibilities. Why? Because 0 is already allowed. Suppose 4 is placed here as the hundreds digit. Then we still have 0, 1, 2, 3, 6, and 7 to take as the tens digit. So assuming 1 is assigned as the tens digit, then we still have 5 left to be the units digit. And therefore, in this particular case, there are 6 times 6 times 5, 3-digit number you can possibly form. And when you say 6 times 5 times 6, is that 180? Yes?
Yes, sir.
Okay, good. So 180. Now, kung ganahan ka, if you don't want to use the principle of counting, And pwede sa ka mag-list down. Unang-una, 1, 2, 3. Next is 1, 2, 4. Next is 1, 2, 6. Then 1, 2, 7. So at least you have listed down already 4. You still need 176. You may continue if you like, no? But take note, along the way, you will also get lost. Ano ba? You will also get lost. So if you will get lost, then you repeat, and most likely you cannot finish it. There are so many. Okay, now if you understand the problem, could you help me solve number 2? How many of these numbers are even? So how do you form an even number? If you are going to form a 3-digit number from the digit 0, 1, 2, 3, 4, 6, 7, the question is, how many of the numbers are even? So how do we solve this problem? Now, when we talk of even number, again, assign gyapon ta og tulo ka boxes, ha? Where this is the hundreds digit, the tens digit, and the units digit. Okay, how do we know that the number is even? If the units digit is an even number. So, unsa man nga mga even number? Ang 0, 2, 4, and 6. So my question is, maybe somebody can share his ideas or her ideas. How many ways could we fill up the units digit? Pangutana daw ta ni Almedelia Lance. Almedelia. Kung wala yung microphone, you just type the answer. How many ways can we assign a units digit if we are going to form an even number? Hello, Almedelia. Are you there? Yes. Did you get the question, Lance? How many ways can we assign a number as the units digit if we are interested of forming an even number? Naritang Laura. Laura, umawas. Si Lance, ningon si Lance 4. Okay. Assuming 4 na. And others probably would also say there are 4 possibilities. My next question is, how many ways you could assign a digit as the hundreds digit? Narita ni Flores, Mark Angelo Flores. Mark Angelo. Mark Flores, are you there? Yes. So Mark Angelo, how many ways can we assign a digit as the hundreds digit? Wala. Ngaritang Mary Villacampa. 6 ko no. Naingon si Angelo 6. Okay, atong subayon ha. Kung unsay flow ini. Okay, earlier, Almedelia suggested 4. Kaya nakakita man siya 0. Kita siya og 2. 4 and 6. And then, he believed that the 4 digits can be assigned as unit digit. And then, ingon si Mark na in the hundreds digit, 6. Posible kuno 6. Okay, atong i-try ha. Nag-assign ko diri og 2. So meaning ang 2 taken out na. Pila naman lang nahabilin? You have 0, 1, 3, 4, 6, and 7. Indeed, there are 6. Pero, can I assign 0 here? Dili man. So, dili ni. Sayop ni. And it might be nga kini siya dili sab siguro na advisable that you would say 4. So in cases like this is what you need to do. Sanang erase, ha? For question number 2, because of the restriction due to the presence of 0, you form 2 sets of 3-digit number. So hundreds digit, tens digit, and the units digit. I-separate nimo ang 0. No? Meaning, you consider a digit number that ends with 0. So if that is the intention that this 3-digit number is a 3-digit number that ends with 0, sorry, na-erase na to. So hundreds, tens, units. Yeah, forma tayo na. Since the intention is to have a 3-digit number ending with 0, so there's only one possibility here. And that one possibility, we are referring it to 0. No other number, 0. So if that's the case, since 0 has been taken already, the remaining numbers are the remaining digits are non-zero. And we have 1, 2, 3, 4, 6, and 7. So kini siya, pwede na ni 6. Onya, this one here, 5, di ba? Because ang 0 is already here. So we still have 6 left. Yeah, 5. But kini nga even number are even numbers ending with 0. Like 1, 2, 0. No? Posible 1, 2, 0. Posible sa 1, 3, 0. Posible sa 7, 2, 0. Then you have to form another group of numbers. Now this time, the units digit is non-zero. So kung non-zero siya and you want it even, you want even number, meaning the candidates are 2, 4, and 6. So this one can be filled up in 3 different ways. I hope you are following. And then for the hundreds digit, since 0 is still there, so this one cannot be filled up in 6 different ways, but only 5. And this one also 5. And in total, you multiply 6, 5 times 5 times 1 is 30. And then 5 times 5 times 3, that would be, laman, 75. 15 times 5, 75. So in total, i-add ni nato. Kay these are numbers ending with 0 and these are even numbers not ending with 0. So in total, there are 105 even numbers. Okay? So we were able to form 180 numbers. And of the 180, 105 are even numbers. Okay, now, you can also solve the same problem by first estimating the number of odd numbers. So kung odd numbers, probably dili problematic. Why? Because 0 is not odd, meaning to say, if we are going to form an odd numbers, there are how many candidates as the units digit? 1, 3, and 7. So all in all, there are 3. So for the units digit, this one can be filled up in 3 different ways. For the tens digit, for the hundreds digit. For the hundreds digit, since 0 is not allowed, we still have 5 remaining. And this one is also 5. So in total, there are 75 odd numbers. So if you are interested of even numbers, you just subtract the 75 from 180. And that gives you still 105. So that's another approach, no? That's another approach. You use the complement set. That's the number of elements not belonging to a particular set, but belongs to the universal set. Is that clear? I hope so. Okay, how many of these numbers are less than 1,300? I think with my discussion in 1 and 2, the third problem is not difficult anymore. So let me show you the solution. So here are the solutions. There are 180 three-digit numbers ending with 0, not ending with 0, in total 105 even. Or you can utilize the add, and there are 75 odd numbers. And you notice I don't have the solutions anymore for number 3 and number 4 because I will leave it as your exercise. Here is another problem. A firm employs 10 programmers, 8 systems analysts, 5 engineers, and 4 statisticians. A team is to be chosen to handle a long-term project. The team will consist of 3 programmers, 2 systems analysts, 3 engineers, and 1 statistician. So take note, there are 10 programmers, but you will choose only 3 out of 10. There are 8 systems analysts, but you will choose only 2 out of 8. There are 5 engineers, but you have to choose only 3. And there are 4 statisticians, but you choose only 1. In how many ways can the team be chosen? Excuse me. Hello, ano, nag-classif ako. Okay. Okay, so we will choose programmers, systems analysts, engineers, and statistician. So for letter A, since we are interested of answering how many possibilities a team can be formed, so this is the solution. Now out of 10 programmers, we choose only 3. And because the order, we're only interested of who are these programmers. The order of mentioning their names, not important. And therefore, it is a combination. Okay, so for example, programmer number 1, programmer number 2, number 3, 4, 5, 6, 7, 8, 9. Morning mga programmers, no? 10. Morning mga programmers. We choose 3. Now, when you choose 3, yung kag this and that, that's one group. Now, if you would say, I will choose 3, 2, and 1, I think you are forming the same group. So you say the order here is not important. It would be a different group. So this is 1 already. It would be a different group if you do it like this. 1, 2, and 4. That's a different group. Or maybe 1, 2, and 5. That's another group. So there are how many ways by which you could choose 3 out of 10? There are simply 10 combined 3 different ways. For the systems analyst, the same. You have 8 candidates, you choose only 2. 8 combined 2. For the engineers, 3 out of 5. So 5 combined 3. And statisticians, 1 out of 4. So there are 4 possibilities you could choose an statistician because there are 4 and you choose only 1. We consider this as sub-events. You can view it as successive or you can view it as simultaneous. Simultaneous or successive meaning you choose first 3 out of 10, then next you choose 2 out of 8, then you choose 3 out of 5, and you choose 1 out of 4, and then you form the team. In total, therefore, now I hope it's not difficult for you to imagine. In total, there will be 10 combined 3. This is now principle of counting. You multiply it by 8 combined 2, multiply it to 5 combined 3, and finally 4 combined 1. Then there are 134,400 ways of forming a team. In the second requirement, naingon man diri sa second requirement, if the customer insists that one particular engineer with whom he has worked before be assigned to the project, in how many ways can the team be chosen? Ang modification, since one engineer has been pre-selected, then you only choose, diba, originally there are 5 engineers, you choose 3. Now this time, because one engineer has been pre-selected, then there are 4 left where you could choose 2. So you can add it to the pre-selected engineer. Therefore, for the engineers, you have now 4 combined 2. 4 combined 2 different ways. And the same, you just multiply all the results. Just say 10 combined 3, 8 combined 2, 4 combined 2, times 4 combined 1. And of course, the number of possibilities can decrease, or it decreases to 80,640. Okay, what about this problem? If a multiple choice test consists of 10 questions each with 4 possible answers, only one is correct. How many different ways can a student check off one answer to each question? Now, what is meant by question number letter A is this, no? So mo ni ang mga questions, 10 questions all in all. 5, 6, 7, 8, 9, and 10. Onya, there are 4 choices, A, B, C, D. So, the question says, in how many different ways can a student check off one answer to each question? It might be that student number 1, pili lang yun siya, letter A, letter A, letter A, and so on. So this is one possibility. Diba? One student would just choose A to all questions. So this is counted as one possibility. Another possibility, no? Another student would choose, I will use another color. One student would choose for number 1, letter A. Number 2, letter A, letter A, letter A, and na. Parihara letter A. Pero pag abot sa 10, pili na siya letter B. So this is now another possibility. Diba? Another possibility. Para dili obvious nga nagkopya lang siya sa 1. Sabay, ang number 10, letter B lang ko. From 1 to 9, letter A lang. Parihata. No? Okay. Now, another student might say, okay, I will use another color, green. So, siya, number 1, letter A sab ko. Number 2, letter A. Number 3, letter A. Number 4, letter B. Number 5, palahi ko, mari ko sa B. Unya, number 6, letter A, letter A, letter A, letter A, letter A. Oh, that's number 3. That's the third possibility. So you can imagine there are how many possibilities are there. Then you just apply the principle of counting. In the principle of counting, item number 1 can be done in 4 different ways. Pwede A, pwede B, pwede C, pwede D. So those are the possibilities. Followed by item number 2, which can also be done in 4 different ways. And therefore, if you apply the principle of counting, then you just multiply 4 10 times. 4 times 4 times 4 times 4, or you would say 4 to the power 10. And in such case, there are 1,048,576 different ways. I think that's clear. Ngarita sa second question. Ang second question, in how many ways can a student check off one answer to each question and get all the answers wrong? Since only one answer is correct, it means to say that for every number, there are only 3 wrong answers. In the second item, there are also 3 wrong answers. So to make it all wrong, you choose only the wrong answers. And therefore, you just say 3 times 3 times 3 times 3. You multiply also 3 10 times. And there are 59,049 different ways. So meaning, kung na-ay quiz ingon ana, niya mo guess ka, then gamay gyud chance nga ma-zero ka. Na-ay chance nga makakorek ka og number. Because out of the 1,048,576, there are only 59,049 ways by which you can get all numbers wrong. So you still have a big chance remaining ini nga makakorek. What about number 3? Ngarita sa number 3 or letter C. In how many ways can a student check off one answer to each question and get exactly 7 correct answers? Unsaon man na? And that question can now be answered using the 10 combined 7, or there are 123 different ways, meaning you choose only 7 and make them correct. And if you choose 7 out of 10, then there are only 120 different ways. Questions, clarifications. Okay, none so far. That's good. This one, ato ning i-analyze. In how many ways can 6 people be lined up to get on a bus if 3 specific persons insist on following each other? Di yun magbuwag, bahala na. No? How many ways are possible? Letter C. If 2 specific persons refuse to follow each other, how many ways are possible? Kana nga mga questions. How do we answer letter A? Ang letter A, in how many ways can 6 people be lined up to get on a bus? Now, when you say you lined up 6 people, the order is now considered important. Diba? Importante ka na kung ikaw maguna rather than ikaw maawahe kung maglinya ka. Malate niya ka. So, if you are going to line 6 persons to get on a bus, the order of the elements is very important. Kung mag-line ka bus, malate na, di naman na pwede ladies first, right? Di naman na mo apply. Ano sila, no? So, Sa ako may nakaunag linya, so ako dire. Number 1, number 2, number 3, number 4, number 5, and number 6. Okay, unya, kining tulo ka persons, yun pwede magbuwag. Amo nang na-late na sila, no? Awahi sila. Because, according to them, okay, we should follow each other. Kana, letter B na nga question. Pero sa letter A, because there are 6 persons and the order of the persons is very important, so letter A can be answered using the formula 6 factorial. So 6 factorial. And 6 factorial, we say 6 times 5 times 4 times 3 times 2 times 1. And that's equal to 720. Okay, so there are 720 possibilities by which you could line up 6 persons to get on a bus. In letter B, tingnan man siya, 3 specific persons insist on following each other. So sa letter B, ang technique ini, sa letter B, you tie these 3 persons. If you tie them up, para di yun magbuwag, nobody maka-insert in between. You tie them up. So when you tie them up, you are reducing the number of groupings to 4 only. And then you can rearrange the 4. So pwede man na kung letter A ni, letter A, letter B, letter C, onya, the last group is letter D. So this is one arrangement. Pwede sab, ang arrangement karon is letter A, onya ang D naadire, doon ang B o ang C, yan na diha. But take note, ang D has 3 elements and they are tied together. So how many ways by which you could rearrange 4 objects? There are 4 factorial different ways of arranging the 4 objects. Now, for each arrangement, pwede na nimo iantay ang letter D. Unya, ang D, moingon ba ka na ay D1, na ay D2, na ay D3. Okay. Now, kining tulo ka elements, pwede man sab na nimo i-rearrange. And if you rearrange them, confined in a space, then I would say there are also 3 factorial different arrangements. Pwede man ka 1, 2, 3, 1, 3, 2, 2, 3, 1, 2, 1, 3, 3, 2, 1, 3, 1, 2. Diba? So 6, 3 factorial. And then, apply the principle of counting. The total event is now divided into sub-events. There are how many ways by which I could rearrange the 4 groups. And then, once we rearrange already the 4 groups, running low na, sakto rasab kay 429 naman, no? Yeah, 3 factorial. You just multiply them. Okay? So that's the solution sa morning solution sa letter B, nga ang tulo ka persons insist on following each other. Ang solution sa 2 persons do not want to follow each other. Then mo gamit ta sabtani o complement, way of complement. So way of complement, ang 6 persons na atong dimension ganiha, 6 persons i-tie up ng duha that do not want to follow each other. I-tie up na. And then you answer it similar to letter B. Okay, if you are able to do that, you are able to answer the question, the number of possibilities in which 2 persons insist on following each other. Now, if the question is they do not follow each other, then you get the complement. And when I say complement, diba, gigroup na nato ang 6, kunya ang duha tied them together. So this will answer the number of possibilities if the 2 persons will insist on following each other. If you subtract it from the total, then katong difference would give us the number of possibilities in which the two persons are not following each other. So this is by involving complement set. I hope it's clear. And I think it's already time, so I will stop up to here. I will discuss probability next week. No, next week. So ang next week, mag-meet ihapon ta sa Tuesday, Tuesday next week to discuss probability. I posted already assignment number 2. That's it for today. I will stop the recording now. Thank you so much. Bye-bye for now.